Hello, Professor. This is Alberto Martinez with Project 1. Okay, to start off, I wanted to go over the main and what's going on here. This is the PLL initialization, which basically sets the system clock to 80 megahertz, which is the core clock of the TM4C123. And with that, we're able to make the appropriate movements according to the clock. Then we have the UART initialization, which is back here. We'll set the UART 0, which is the one that's able to communicate with the computer and the microcontroller together, and that is on port A1 and port A0. We make sure to set the baud rate to 115,200 with an 8-bit word length and no parity bits, 1 stop bit, and FIFOs activated. Then we go ahead and enable the UART with which is a digital with alternate function, and we disable analogs altogether. Going back to the main, then we have the CECS initialization, which is up here. It essentially just sets up periodic interrupts. It doesn't put a reload value in it just yet. We do that in a separate function, but this just initializes it to begin with. We then have this reset value here is, you can see down here, the first time I don't get any input from my UART. That is because I want to go into the sine value directly. Just always start off at 262 hertz on a sine wave, and that's the way I approach that. And I also tell it that it starts on a sine wave, and this is the title of the project. Okay, so every single time we go into our super loop, well, the first time, like I said, we're going to ignore this part and just output a sine wave at 262 hertz. However, every single other time it will do the entire program, which is it will take the UART inchar, which is over here, which essentially just takes it's going to read a value from our keyboard, and it will let us it'll wave down a flag. It'll set it to 0, and it'll let us know that there's something in our FIFO or in our communication that is kind of waiting for us to use it. And we will take that data and put it into key in here, which will tell, we will then use if-else statements to choose what data was given to us and output. For example, right here we're outputting a triangle wave, and this UART out string is outputting this message into the serial communication, which is created by PuTTY. And it will output this message and save the state, and it will also do this right here, which is get pitch. Get pitch is a function up here that basically sets the reload value for the CECS every single time. And the reason we want to do that is in order to get the CECS, the periodic interrupt that will interrupt the frequency of each wave, so how fast the wave is going essentially. And by doing that, we can change the pitch at which the wave is presented. And every single time this happens, we also jump into the handler up here, the CECS handler, which will index through each one of the corresponding waves. Depending on what was the input from our keyboard, it is saved, and then it is read here in this if-else statement, and it will output the corresponding wave, so a sine wave, or if it was T, a triangle wave, Q is a square wave. And that is how we are approaching that. And yeah, that's basically the bulk of it. Now to the demo. If we open up our serial communication, you'll see here PuTTY is going on, and we have our sine wave being displayed at 262 hertz. And in order to double check that, I have this thing here which shows that it's running at 262 hertz. And then depending on what key I press, so this is 262, this is going to be 294, and it's basically one whole key above the other, depending on what button I am pressing. And to show you that it is changing up here, I have C, G, E, F, G. I went down to F, just double check it. Yeah. G. Let's go to A, B, and then back to C. Now, the other functionality of it is changing it between the sine wave and the square wave. Oh. So this is back at 262 hertz of a sine wave, and if we could change it to a square wave, you see that the frequency here doesn't change. However, the wave is changing between a sine wave, square, and triangle. And that is the bulk of the project. I will send you what the waveforms look like, given that I don't have an oscilloscope in order to show it, but I will send you those pictures using the linear function regulator. And yeah, if you have any questions, let me know. Have a great day.